of what do you need for the lab, I'm going to provide a link here. No, I don't need that. TDSB, copy link, done. So you should have access to that. Now this video, there will be some stuff that is not on, that is easier for me to just show on paper rather than typing it all out, okay? So I'm recording the video. There's a lab format guide that you have. You will have a sample paper. I just need to find one and put one up there. Deadline. Because when we come back, we're back on the 9th. We have 1 week, 2 weeks, and then 2 days. So we only have 2.5 weeks when we come back. I want you to not need to think of anything else except the exam. Okay? After the lab. So the lab will be due on the 13th, Friday that we got back. Okay? E-copy, 6 a.m. in the morning on Brightspace, hard copy in class in the beginning. Okay? Now, there is no formative feedback draft offered for this lab. Okay? At this point, you have written 2 lab reports. So you have, if you got the formative feedback from before, you actually have 2 personal feedbacks. Actually, no. Even if you didn't get formative feedback, you have 2 personal feedbacks from your previous lab and 2 common feedbacks from your previous labs. And if you get formative feedbacks, you also get to see those too. So hopefully by this time, you kind of have a good idea of what is the expectation. Also at the same time, so this here, I have the link to the osmosis lab so you can see some of the common feedback, link to the catalase lab so you can look at the common feedback. Okay. Also use a sample paper. I'll be giving you that. Okay. So what do you need? This lab will will be the full lab from beginning to end. You don't need a cover page. Please don't have it. Just have page number. Heading should be in bold, used binomial names. Okay. We're not dealing with potatoes. We are dealing with various seeds. I'm not going to change it now. You can still use this template. The background, same idea. Variables, apparatus, method, procedure, safety plus ethics. All this remain the same. Now, someone asked me a question. How do we know the uncertainty? Now, uncertainty for other stuff, like time, like volume, those kind of things, it's still the same. The only thing special about uncertainty for this one will be the sensors. So in this case, what you should do is this. Go to vernier.com. So go to vernier.com. You go to products. You go to sensors. And then you have a whole bunch of sensors. Okay. Look up the one that your group was using. Okay. So this one, the Go Direct O2 gas one, that's on the first page. I know there's only one of them. Huh? Yeah, you can figure out. Yeah, $300 a pop. That's why I told you guys, don't break them. If you go to the specs, and you see here, accuracy is plus or minus 1% oxygen. Now, you might remember, it's like, wait a minute, our units were in ppm. The percentage part doesn't help. In this case, you just look up what's the conversion rate between percentage to ppm. I just look it up. Oh, 1% is 10,000 ppm. So in this situation, if you're the lucky group that used that particular sensor, your uncertainty for the sensor will be plus or minus 10,000 ppm. Okay. Now, if you are using the other sensors, do check what is their specific accuracy. Okay. It could be and most likely be different. You guys good? Results. So here, there's a link that shows you how to show lab. Again, collect data, raw data, qualitative observation, process data table, sample calculation, group, graph, trend line, R2, error bar should be standard deviation of that variation. Now, for this section, I should talk a little bit about it since this lab has been a while, and the data processing part you might not remember much. So if you remember the lab, you had 4 flasks of whatever seeds you were growing. You are either measuring the CO2 or the O2 concentration, okay? And every day you should have about 4 graphs, okay? And you run it for 600 seconds. And I did ask you guys, find the section that is the flattest or the most linear, find the slope and rate of change. That will be your M/1 of day 1. Okay? So in this case, your raw data table should be something like, oh yeah, day 1, flash 1, what is the rate? Day 2, flash 2, what is the M? Day 1, flash 3, what is the 3? By the way, this is recorded. Okay. And then you have the same thing, day 2, day 3, day 4. Okay. If you don't, I don't remember whether some people do day or some people do hours. It could be hours. That can happen. Because I remember one day, instead of doing it at that particular time, we had a test, so people had to do it over lunch or even afternoon. So I should not see 16 of these kind of graphs. I should not see 16 of this kind of graph. I should only see 1. What I mean is this. After this is a raw data table, you calculate the average M for day 1, average M for day 2. You also do the standard deviation of that set. You plot the graph on Excel. Please don't use numbers. Please don't use Google Sheets, okay? Because you have individual error bars that has to be different size, okay? Those are really tricky to do. Use just Excel. You plot the average rates of every day. You do it. You need to have a trend line. You need to have standard deviation as error bar. You do need to have the equation and R2 values. Okay. Now, as part of the sample calculation, aside from you showing me how you calculate the average and the standard deviation, I want to see just one of those 16 graphs. You pick one, the best one that you can think of, or the best one you can think of, and show that as a sample, so that if I read it or another biology teacher from this school read it, they would understand, oh, so this is how they got those raw data number. Okay. So I should see one graph of the average M and one graph of those from the sample from the graphical analysis. Okay. Any questions on this section so far? No? Okay. Also, if you're not sure, I believe on the unit planner there are two videos. YouTube. I'm just going to put the link of those two videos here. Nephrons, respiration rate. Yeah, respiration rate lab of mung bean, respiration. Yeah, so there are two videos. I'm going to put the two videos here again, link again. So you have a lot of stuff. Link to video 1 of setup. And link to video 2. This is about data processing. Okay. Yep. Sorry. No. Okay, so there are the two videos. Okay, you can look. Now after that, discussion, talk about your trend line, refer to it in detail, give scientific explanation of the trend. Is there anything in the procedure that might influence your result? Please don't talk about human errors. No talking about human errors. Okay. That is really the time to talk about your uncontrolled variables. Compare your data with published sources. Make sure you only use reliable source. Now, what this means is this. There might be similar experiments of other seeds or the same seeds. Then you talk about it. Or because you have to give scientific explanation of your trend, maybe you can find some published sources that will confirm or disagree, confirming or disagreeing with your scientific explanation. Yes, yes. Okay. Uh, since this is a lab report, you may use encyclopedia. Okay. Really, between Britannica and encyclopedia.com, it should cover most things. Okay, make sure you use in-text citation APA. Strength of the method, reliability, correctness, general issues, and of course, flaw, limitation, and improvements. Okay, so that is your final lab report. That is your final lab report. So it will cover all this. I would say try to keep it 15-ish page. Try to keep it 15-ish page because I remember reading some people's osmosis lab and catalase lab. Those are half labs, but those are already 15 pages. Okay, so keep it. When I say 15 page, I'm talking about double space. Like if you use single space, like 7 to 8 pages. Okay, keep it to there. Okay, you don't need to write huge, huge. Any questions? Okay, so I'm gonna stop recording this.